So we are going over to rule 4. Rule 4 says that when the same side chains appear more than once, the multiplying prefixes di, tri, tetra, etc. are used to denote their presence. So this is actually what rule 4 is saying. Let us get to understand what rule 4 is saying. We proceed back to looking at what rule 4 is saying. Let us take a look at rule 4. So we have this structure CH3, CH2, CH, CH, CH3. CH2, CH, CH, CH3. And we have drop down CH3 and another CH3. So let us take a look at how we can name the compound. Following our rule, the first rule is we have to identify the longest continuous chain as the parent chain, and then whatever is not in the parent chain becomes side chain. And of course, we have just seen a rule, the third rule, and the third rule we have just seen tells us that if two or more chains are of equal length, the straight one should be considered the parent chain. So now we are looking at a rule which is saying that in a given hydrocarbon chain, there is possibility that we may have two or more side chains of the same kind. So if such happens, the multiplying prefix di or tri or tetra is used to denote that there are two or more side chains that are of the same kind in that hydrocarbon chain. So let us get to see what we really meant by that rule. Now, looking at the board, students, we have it that if we are to go straight in taking our accounting, this will be 1, 2, carbon 3, carbon 4, and this will be carbon 5. So it means that I may choose to take my counting straight this way. With a pencil, I map it out. I map my parent chain. But another student may choose to go the other way around. Another student may choose to go by this way. Let's say another student may see it the other way and say, no, I don't want to use this method. I don't want to go straight. I really want to go another way. So you have to be very careful not to count less. If I choose to count this way, if a student chooses to take his or her mapping this way, maybe this way, this way, this way, this way, and that way, the student may choose to take his or her counting this way. And this is also 1, 2, 3, 4, and 5. So you can see. So whichever way you choose to take your counting, you should be very, very mindful. So this is actually how this can be marked. But we still remember the previous rule which we have just seen, that if we have different numbering schemes, that the straight one should be considered as the parent chain. That is actually the rule. So having seen that, let us now proceed to looking at how to name that compound. So this goes away since we are going to concentrate on the straight chain as our parent chain. And we have 3 here. So looking at the compound above, the hydrocarbon chain compound above, what will be the name of that compound? Now, the first thing to do is we need to number the parent chain. Where do we start numbering? Do we start numbering the parent chain from the left-hand side or from the right-hand side? To answer that question, we need to consider if we start numbering from the left-hand side, the side chains CH3, oh, sorry about that. We're going to just take this off. We're just going to rewrite that. CH3. So, if we choose to go from the left-hand side, this is CH3, and this is another CH3. So, it means that the first CH3 will fall under carbon 3, and the second CH3 falls under carbon 4. So, it's going to be 3, 4 CH3. But if we choose to come from the right-hand side, it means that coming from the right-hand side means that this is going to be our carbon 1. Here we have carbon 1. Here we're going to have carbon 2. And here we have carbon 3. So, if we choose to come from the right-hand side, the first CH3 will be at carbon 2, and the second CH3 will fall under carbon 3. But if we choose to go from the left-hand side in numbering, we are going to have 3, 4. That is to say, the first CH3 will fall under carbon 3, and the second will fall under carbon 4. So, now, where do we follow? We remember our rule which says that we will have to follow the route that will give the side chains the lowest number as possible. So, since that rule already exists, how do we go about? Where do we follow, right or left? We ought to follow right-hand side. So, we follow the right-hand side in doing our numbering. So, when we follow the right-hand side, it means the first CH3 will fall under carbon 2, and the second falls under carbon 3. So, what will be the name of that compound? The name of that compound is going to be 2,3-dimethyl. 2,3-dimethyl pentane. It is pentane because there are 5 carbon atoms in the parent chain. Now, someone may ask again, how did we come about this name? I don't understand. Now, this is how you have to understand. When you have mapped out your parent chain, count the number of carbon atoms in the parent chain, and then write down the name of that parent chain. So when we count, we have counted 1 from the right-hand side, 1, 2, 3, 4, 5. There are 5 carbon atoms, and 5 carbon atoms from the right-hand side gives us pentane. 5 carbon atoms is pentane because it is not having any double bond. It is just all single bonds. So 5 carbon atom is pentane. Since it is pentane, we have side chains, and these side chains are attached to the second carbon atom and the third carbon atom of the pentane compound. So, since it is that way, the first methyl and the second methyl attached to carbon 2 and carbon 3, it means we have to identify and acknowledge their positions because they are attached as methyl groups. So, it means that the first methyl, methyl A, is attached to carbon 2, and the second methyl, methyl B, is attached to carbon 3. So, what would be the right name? If we are to go from the right-hand side, we are coming from the right-hand side, the methyl groups will be at carbon 2 and carbon 3. But if we are to come from the left-hand side, the 2 methyl groups will be at carbon 3 and carbon 4. So, we ought to give the side chains the lowest number as possible. So, that means we will come from the right-hand side, and that gives them 2 and 3. position 2 and position 3. So this is 2, 3. Numbers are separated from numbers with a comma, while numbers are separated from letters with a hyphen. So this is our compound 2,3-dimethyl 2,3-dimethyl pentane. So let's take a look at the next structure. CH3, CH2, 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 CH with a drop down on CH3, another CH with a drop down on CH3, and the last CH3. So let's take a look at how to name such compound. So we have CH3, CH2, 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 CH with a drop down CH3, CH, a drop down CH3, and CH3. So the question is, what is the name of this hydrocarbon? To name the hydrocarbon, we have been told to take the longest continuous chain. The longest continuous chain is our parent chain. The longest continuous chain will be our parent chain. And how many carbon atoms are there? 1, 2, 3, 4, 5, 6, 7. There are 7 carbon atoms in that chain. Once again, I would like to make you understand, dear students, that you must not always go straight. You can also choose to go this way, only that there is a rule that says when we have different numbering schemes, the straight chain should be considered as the parent chain. That is to say, the straight chain should be given preference. That's all. Otherwise, you can also choose to take your parent chain like this. You can also choose to take your parent chain as 1, 2, 3, 4, 5, 6, 7. I may choose to come down this way. I may choose to go this way. So whichever way you choose to go, it doesn't change the structure's name. It will not change the structure's name. It still remains the same, whichever way you choose to follow. So you're still having 7 carbon atoms. You are still having 7 carbon atoms. So nevertheless, let's still leave both of them so that you can get to understand that whichever way you choose to take your parent chain, you are still getting the same name. So we are going to just see how that works now. Now, looking at the structures, as we can see displayed on the screen, please take note that they are the same. Nothing has changed. The only thing we did was to take another route instead of taking the straight chain. It's just to take another route, but it is still the same thing. Now, having seen that, it means that for A, let's call this A and call this B. So it means that for A, we have 2 side chains, methyl and another methyl. For B also is the same thing, methyl, methyl. So let us now take a look at how do we name this hydrocarbon. To name the hydrocarbon, the rule says we should number the parent chain. How do we do our numbering? Do we number the parent chain coming from the right, or do we number the parent chain coming from the left? That is the question. Do we go from the left-hand side or from the right-hand side? Now, if we are to come from the left-hand side, it means that from the left-hand side, this will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. But if we are to number the parent chain from the right-hand side, then this becomes carbon 1, 2, 3, 4, 5, 6, and 7. So, where is ideal? A rule says that if we have identified our parent chain and our side chain, we should number the parent chain. And the numbering should be done in such a way that the side chains are given the lowest possible number. So if we are to go by that rule, it means that coming from the right hand side, we attach a lower number to the two side chains attached to this parent chain. So automatically it means that we will be coming from the right hand side. And the right hand side gives the side chains position 2 and position 3 as against position 5 and position 6 if we are to come from the left hand side. So having seen that, let us now take a look at the name. What therefore will be the name? The parent chain is 7 carbon atoms, and 7 carbon atom is heptane. Heptane. So since 7 carbon atom is heptane, the next we have to ask ourselves is, what are the side chains? The side chains are methyl side chains, and there are 2 side chains there. The next question is, where are they attached to? These 2 side chains are attached to carbon 2 and carbon 3. So it means that we are going to identify their positions as 2, 3. 2, 3. The methyls are at position 2 and position 3. So since it is like that, how many methyls are there? There are 2 methyls. Since there are 2 methyls in that chain, it means that we are going to call it dimethyl. Dimethyl. Now, since we have identified that there are 2 methyls, dimethyls, the question now is, where are they located? They are located at position 2 and position 3. So we also have to indicate position 2 and position 3. Now, a rule says that numbers are separated with a comma, but numbers are separated from letters with a hyphen. So automatically we have formed the name of that hydrocarbon, and the name is 2,3-dimethyl-heptane. So the name appropriately is 2,3-dimethyl-heptane. It's as simple as ABC. Now, it is for the compound A above. Let us consider if B is also going to give us the same naming. Let us take a look at if B is going to give us the same naming. Now, to make it clearer, let us see how to rewrite B again. This is B. Let us see how to rewrite it again so that we can be cleared. No matter the route you choose to follow, it is still the same thing. CH3, CH2, 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 CH, drop down, CH3, CH, drop down, CH3, CH3. And instead of taking the straight parent chain, we decided to pick the L-shaped parent chain. Now, since we decided to pick the L-shaped parent chain, where do we start our numbering from? We still have to obey the rule that says that, having identified our parent chain, that the side chain should be given the lowest possible number. So it means that if we are to come from the right hand side, we are going to have less numbers for the side chains compared to if we are to come from the left hand side. So from the right hand side, this will be our carbon 1. This stands as our carbon 2. Here is our carbon 3. This is our carbon 4. This is carbon 5. This is carbon 6. And this is carbon 7. So we can see now that even if we choose to go straight or we choose to go curve, our methyl is still attached to carbon 2 and carbon 3. And the parent chain here remains 7 carbon atoms, which is heptane. And there are 2 side chains there that are of identical species, identical group, and these species are called methyl. So since there are 2 methyls, it means we are going to call them dimethyl. Since we have identified that there are 2 methyls and we have identified them as dimethyls, the next question is, where are they located on the parent chain? On the parent chain, they are located at carbon 2 and carbon position 3. So it means we have to indicate their position 2 and 3. So since we've done that, we will now recall that numbers are separated with a comma, and also numbers are separated from letters with a hyphen, and it's as simple as that. So we can see the names retains 2,3-dimethyl heptane.